Hello guys, it's your favorite teacher, Godson, and you know what it is. This is Wits Lounge, Learning Made Easy. Today, we are going to be studying Faraday's second law of electrolysis. Faraday's second law of electrolysis. In Faraday's law, we are dealing with the same substance, but when you come to that's Faraday's first law, we are dealing with the same substance. But when you talk about Faraday's second law, you are dealing with different substances. Faraday's first law, same substance. Faraday's second law, different substances. So let's get to work. What do I mean by that? We earlier stated that Faraday's law, first law, states that the mass of a given substance is directly proportional to the quantity of electricity passed through the electrolyte. So we have that for Faraday's first law. But in the second law, we are going to be dealing with two or more different compounds. So let's state it. It states that when the same quantity of electricity is passed through different electrolytes, when the same quantity of electricity is passed through different electrolytes, the number of moles deposited is inversely proportional to the total charge or total number of electrons transferred. I take it again. When the same quantity of electricity is passed through different electrolytes, when the same quantity of electricity is passed through different electrolytes, the number of moles deposited is inversely proportional to the total charge or total number of electrons transferred. Now, this is a simplified way of stating it because you could have another way of stating it. Some other textbooks or in some of your other research works, you find out that it is stated in this way, that when the same quantity of electricity is passed through different electrolytes, the mass of the substance deposited is directly proportional to its chemical equivalent. Whether you are using the chemical equivalent principle or the one I stated earlier on, they would eventually give us the same mathematical expression. So I had to state it in this way because it's more simplified and easy to understand. So I take it again. Faraday's second law of electrolysis simply states that when the same quantity of electricity is passed through different electrolytes, when the same quantity of electricity is passed through different electrolytes, the number of moles deposited is inversely proportional. The number of moles deposited is inversely proportional to the total charge or total number of electrons transferred. Okay, so we have that. Now let's get to the board. Before we get to the board, I meant to say, let's take note of two things that in describing Faraday's second law. Number one is that you must pass the same quantity of electricity through the electrolytes. And secondly, it involves different electrolytes. So whenever you have an exam question and you notice that in that question, you are relating different electrolytes and you notice that the same quantity of electricity is passed through those different electrolytes, my brother, my sister, you are supposed to use Faraday's second law of electrolysis, provided you are dealing with a relation between the number of moles deposited and the charge. And that's that. So I take it again. Faraday's second law simply relates the number of moles to the total charge, and that relation is only established if the same quantity of electricity is passed through different electrolytes. Okay, so let's try to express it mathematically to see what we mean. So what do we mean when we are talking about the mathematical expression of Faraday's law? Number of moles, number of moles is inversely proportional to the total charge. So we have N equals number of moles and C equals total charge. So with that said, this could also imply the total number of electrons that is being transferred. We'll look into that. So with that said, we have, putting our proportionality, remove the proportionality sign, we have N is equals Q over C, where Q is constant. And if you have Q as constant, what do we have? Q is going to be equals NC, which leaves us with the relation N1C1 equals N2C2. Now, what does N mean? N1 is number of moles of a given substance, while C1 is the total charge of said substance. Then we have N2 as number of moles of another substance. Why I'm emphasizing this is for you to understand that in the second law, we are relating two different substances. I'm trying to make it as simplified as possible, such that when you look at a question, you know what formulas and what laws to use. If you look at a question, and in that question they simply said that the same quantity of electricity was passed through different electrolytes, and you are relating the number of moles deposited to the charge or the total charge in that particular electrolytic setup, please, no other questions should be asked. You are supposed to use Faraday's second law, and specifically the formula that is used to relate that is N1C1 equals N2C2, where N1 is the number of moles deposited for a given substance and C is the total charge for that substance. N2 is for another and C2 is the charge for that particular other substance. So in the first law, we are dealing with the relationship based on the same substance, but in the second law, different substances. So what do we mean by that? We'll get to answer questions, but before we get there, there are other relations that we can derive simply by understanding this particular formula. And what is the relation? If I may, I would have to take this out. Now, did you notice that Q is constant? Because we said in Faraday's second law that the same quantity has to be passed through different electrolytes. Saying the same quantity of electricity implies that the quantity of electricity remains the same. It is constant. So that's why Q is the constant in this case. Okay. So having established that, what do we get to? We have that N1 C1 is equals N2 C2 as our first formula. But we know that number of moles is equals mass over molar mass. The implication is anytime you are given a question and instead of number of moles, maybe you are asked to find the mass deposited instead of the number of moles deposited, what are you supposed to do? Or what is the formula you are going to use? Very simple. If you replace this number of moles with mass over molar mass, you have a new formula. Your new formula, instead of N1, it will be M1 over MM1 times C1 equals M2 over MM2 times C2. And that's that. All I simply did to generate this formula was I have that according to stoichiometry, N is equals mass over molar mass. I take it again. N, let me put this down fully. Number of moles is equals mass all over molar mass. So once you're able to do this and you put it here, wherever you see N, replace it with mass over molar mass. And if you have this, you have gotten a formula that involves mass directly. You don't need to solve for number of moles and then change it. Once you have this formula in your head and you are relating different masses of different substances deposited with the same quantity of electricity passed through both electrolytes, you have this particular formula to relate the two of them. Okay, we go to the next one, which is the third relation. Some of the times gases are actually produced in these cases, and the gases that are being produced in this case are measured in volume most of the times. So instead of measuring it in number of moles, we need to use a volume relation. And what is the volume relation going to be? N is equals volume in dm cube divided by 22.4 dm cube per mole. So it implies that wherever I see N, I can replace it with volume over 22.4, and then I will still get my same relation. I don't need to first solve for N and then convert it to volume. With these formulas directly, when you are asked volume, you just put it there and you solve. So what do we have here? V1 in dm cube all over 22.4 times C1 is equals V2 in dm cube all over 22.4 times C2. And that's that for the volume. There are other scenarios where in one electrolyte you have a mass of a substance deposited, and in the other one you have a volume. So how do you relate a particular question where one side is mass, one side is volume? It's very simple. You use the number of moles equivalent relation to mass for one side and use the number of moles relation to volume on one side. So we are going to have another formula where we have mass over molar mass times C1 is equals volume over 22.4 times C2. Remember, this is in DMQ. And you have that. So you can actually generate as many things as possible simply by understanding that number of moles is related to other quantities of measurement. And once you apply those quantities of measurement into this formula, you have created your own. Okay, so with all this stated, we'll try one question. What question is that going to be? So right, everybody, 10.8 grams of silver was deposited by passing 10.8 grams of silver was deposited by passing a given quantity of electricity through a silver voltmeter. 10.8 grams of silver was deposited by passing a given quantity of electricity through a silver voltmeter. If the same quantity of electricity is passed through a copper voltmeter, if the same quantity of electricity is passed through a copper voltmeter, what is the mass of copper deposited? Now, let's look at this question. Now, this is quite simple to understand. Very easy, because I said something. Now, whenever you have a question and you're expected to use Faraday's second law formulas, the first thing you need to note is that the same quantity of electricity has to be passed. And secondly, you must be dealing with two different substances for you to use any of these formulas in Faraday's second law. And that's quite simple to understand. So, if you look at our question, they qualify to apply this principle to, because we have the same quantity of electricity passed. It was mentioned in the question. And then secondly, we have that different electrolytes are involved. So with that said, let's get to solve this question. The question has mass deposited. So we are going to be using a particular formula relating two different electrolytes, but then we are relating their masses. And that will be formula number 2. So we have a question. The first mass is that of silver, and silver, the mass deposited is 10.8 grams. The molar mass of silver, as we know, is 108 grams per mole. Then, what else do we need? We need the charge of silver. Yes. For us to get the charge of silver, we will need to perform the electrolysis of silver. What happens when silver is chemically decomposed? So what is that going to be? The reaction of silver occurs at the cathode, and at the cathode reduction occurs. So we are going to be discharging silver ion to see what we are going to get. Now, when you discharge a cathode or a cation, you discharge a cation by accepting electrons. So we are going to add electrons, and then we have Ag solid. If you haven't understood the principle of balancing redox reaction, you need to go back and watch those videos, because it's going to help you understand how to balance these equations. With this said, Ag plus electrons, what do we have? We have 1 balance, so we go to balancing charges. The total charge here is 0, total charge here is 0, so we don't need to include an extra electron, and that's that, completely balanced. Now, the total charge C is gotten by the product. When you look at this particular scenario, you will notice that the ion has +1. That is the charge of the ion. But when you're looking at the total charge, you are multiplying number of moles by the charge. So total charge C equals number of moles of ion multiplied by the charge it carries. So imagine we had 2 here. The total charge will now be +2. It is not just the oxidation number of the ion. But when you talk about C, C is the total charge, which is equivalent to the number of electrons that is being transferred. Have that in mind. C is not just the oxidation number. For instance, if you have oxygen, O2 minus, the total charge in that particular reaction is not -2. The reason is because there are 2 moles of oxygen being discharged every time it's going to be discharged, and for those 2 moles, it's going to be 2 moles multiplied by the 2 charges. So the total charge is going to be how many? 4. So have this in mind. Total charge is gotten by number of moles of ions multiplied by the charge. And in this case, our C of Ag is going to be equals, what is the total number of moles of the ion? We have just 1, multiplied by the charge, which is +1, and then what do we have? 1. So we've gotten C of Ag. In the case of copper, we have Cu2 plus E minus reacting to give CuS. However, the elements are balanced but the charge is not. So what do? We introduce 2. Go and look up our video on balancing ionic redox equation and you understand why this is 2. So with this as 2, we have that it is balanced. What is the total charge? 1 number of moles multiplied by 2, which is the charge, and you have 2. Or you look at the number of electrons that was transferred, it is equivalent. The values are equivalent. So have this in mind. Total charge and the total number of electrons transferred for a balanced redox reaction with respect to electrolysis is what would give you your value of C. Okay, having said that, the C for copper is going to be equals to in describing the values of C, we most times do not consider the sign, whether plus or minus, so just have the values. Okay, so I take it again. We have the mass of silver is 10.8 gram. The molar mass of silver is 108 gram per mole. You have silver discharges and it's discharged by addition of 1 electron, which implies that the C, or the value of C, is equals 1. You come to Ag, copper I meant to say. When copper is discharged, 2 electrons are involved. Therefore, the value of C is 2. I also told you another way of finding the charge C, total charge C, is by multiplying the number of moles by the charge of that particular ion and you get your value for C. Remember, for you to do that, your equation has to be balanced. Okay, so let's get to solve this question because it's now getting too long. I was just trying to explain. Okay, we are using this. The mass of silver is 10.8 gram. The molar mass of silver is 108 gram per mole. What is the charge, or the C in this case for silver? We said that C of silver is 1 because only 1 electron was actually added for you to discharge silver. So, equals. In the case of copper, we are looking for the mass of copper. The molar mass of copper is 63.5 multiplied by the charge of copper, which is 2. If we cross multiply, the mass of copper is going to be equals 10.8 multiplied by 1 multiplied by 63.5 divided by 2 times 10.8. So with this said, if you have this, what is going to be our final value? Our final value is going to be MCU equals 3.175 grams. Now, there's this thing about metals. The charge of a metal is exactly the same thing as its total charge. So whenever you're dealing with the value of C, just look at the charge for any metal and you have their values. Okay, with that said, it means that aluminium C would be +3, magnesium will be 2, sodium will be +1, potassium will be +1, because in this case, we have generally noticed that the C, which is the charge, the total charge for a metal, when it is being discharged during electrolysis, is the same thing as the charge of that metal. However, when you're dealing with gases, it is a little bit dicey. Most times you have to multiply by 2 because they are diatomic. So I believe that with this video, you have been able to establish or understood the different laws of electrolysis and how to solve questions with respect to them. More videos will be coming up. Thank you very much for watching. Remember, this is Wits Lounge, learning made easy.